Hello and welcome everyone to the Tech Sharmit Podcast. Today I am here with another special guest, Mr. Karl-Erik Stenfors. If I talk about Karl, then he is highly regarded uh, independent IT consultant known for his work in Linux, virtualization, and mainframe basic skill. Not only this, he is a respected textbook author. He has written various textbooks for IBM community and has been honored as an IBM champion for three consecutive years from 2022 to 2024. In this episode, we will talk about Carl's extensive career in the mainframe industry, his international experiences, and the significant changes he has witnessed. But before we start the discussion, I'd like to thank Carl for joining us today in this episode. And now I request you to please initiate the discussion by telling us something about yourself.
Thank you so much. I'm very much honored to be invited to this because you're part of the world I have never visited or even worked with. So I find this very interesting and I'm very happy to join you. Well, I'm a retired IBM systems engineer. I retired about 13 years ago after more than 40 years in the mainframe space. The last 26 years of my career was with IBM. Before that, I was started as a very young systems programmer back in the early 70s. Then moved on to do some operations in Nigeria, and then a consultant where we developed modifications to the operating system to better suit the needs of what we were doing at the time. I then joined Amdahl for a couple of years to help marketing and introduce the first partition-level mainframe, the 5860, with something called MDF, which was basically a way of cutting the machine in several pieces. That being done, living in Norway, which is a very small country, people knew about that. So IBM asked me to come and join them in what was called the Field System Center, second level support, because they were going to announce the Prism or the LPAR. So in 1987, I wrote my first red book introducing the LPAR or the Prism into the mainframe space. After that, I worked on the mainframe throughout my career at IBM, things like early support programs, customer advocacy, and so on and so forth. And in 2011, I retired, thinking I would leave the world of IT. So I went into university and did political science for 4 years. And then just, one of these things that happened, and a connection that I'd known called me in 2015 and said, "Can't you come and teach?" So I did that. So I've been teaching Linux, I've been teaching virtualization, and recently also picked up assembler, and I'm still doing that. So I just got my first planning for the next year. So it's an ongoing thing for me. I enjoy that a lot.
Okay. Yeah, so thank you so much for this introduction, Carl. And as you mentioned that you have worked in various countries, including Nigeria, UK, and France. So how did working in these different environments shape your career and perspective on mainframe system?
Well, I think the most important part was not really the mainframe as such, but I'll give you some examples. It was more the different cultures in the different countries. I come from Scandinavia. I'm Danish, and we are a little bit rigid, if you will, psychology rigid in terms of how we work. And then coming to work in places like France, in Africa, was very different. A good example, we were sysprocs, so we did everything ourselves in Scandinavia. We changed paper, we changed disk packs, and so on and so forth. So we went to help an installation in the UK, two of us, and there we were not allowed to touch anything but the console, right? So there would be operators working with us over the weekend at night and so on could you please change that disk pack, or could you please adjust the paper? But where we came from, we just did that ourselves. So I think the mainframe as such was not that important. It was more the different cultures of how you work together, how you work with people. When I went to Nigeria, one of the big problems there was getting people into work at the correct hour, because the transport system was completely overloaded, if you will. I also worked a bit in the US, and I liked that a lot, because in the lab environment, there's a deep respect between the people working there. So more than technology, I think the idea of working in different countries really opened my eyes to the differences between people. As I say, I tell my kids have been traveling all over the world, just to get this different approach to things, not only thinking we do the right thing where we come from, right?
Right.
And a real eye opener, I would say.
Okay. Okay. And reflecting on your entire career, like you have experienced various things related to COBOL and other technologies as well, mainframe and other technology as well. So, what are some of the most significant changes you have witnessed in the mainframe industry? If I particularly talk about mainframe, then.
Well, the most important, of course, is the 7th of April 1964, when the mainframe was announced, because they changed things in the IT industry, but they also changed the way people do businesses, right? And I firmly believe it was down to the fact that for the first time we had an environment where they separated the architecture from the implementation, right? So with the 360, they could build small systems using a certain level of technology, and they could build the same architecture for the 192, which was the world's most powerful computer at the time. And they did that by using different technologies. That opened the door for, say, even the corner shop could install a 360, and so could the biggest banks and so on. So you would have this whole community of mainframe users, from the very, very small to the very, very big. So they not only did they change the computing industry, but they changed the way we do business, and the way we do business even today. Now, if you then move a little bit forward on from, well, one more thing, the system was designed to support more than one user. So there was a very heavy protection between the different users of the system put into the architecture and into the implementation. To me, the next big thing was virtualization, right? Because that has been going on, that discussion has been going on. And one of the key problems here was, how do I translate a virtual address to a real address? And IBM and others worked on a solution where you actually built a piece of technology that could do that on the fly. And we saw that on very late on the 360 history. And then, of course, into the 370 also, where it really took up. And one of the side effects of that was, to me, the appearance of the VM operating system. To me, it's probably one of the most important operating systems in the industry, even today. And I'll come back to that a little bit later. So the way that we could virtualize things also helped IBM itself. For instance, the development of MVS and other operating systems were heavily based on using VM to drive these environments. The next big thing for me was the say early 80s, where IBM introduced the extended architecture, extended addressing, etc. And on side of that, they invented what they call the SI instruction system, a start interpretive execution, which basically allows a very high number of virtual guests running on VM with near native performance. And that was also, of course, used in the LPAR. So when the LPAR came out on the 3090E, 87-ish, I wrote the red book for that. So I knew that pretty well. So that was very key. And then came another bet your business in the beginning of the 90s, where a couple of visionaries in IBM, Nick Donofrio and the head of the system C at the moment, a lady, and the name escapes me at the moment, I'll get back to that. But they basically went to Gerstner and said, we need to change the basic technology. because the technology we are using is coming to an end. This was the technology that demanded water cooling and all these big machines, etc., etc. So they said we should try to move the mainframe technology onto CMOS. There had been a lot of work on that going on, especially in Böblingen in Germany, where we could then reduce the number of components. But the big problem was, of course, that the then CMOS processor, when it came out, it was about 25% of the power of the existing processors, right? So that was a big change. And what then happens here is that the competitors, Fujitsu, Hitachi, etc., they continued developing the old technology and built machines that were very, very powerful. The base for that was, of course, that in the early 1970s, IBM was forced into unbundling hardware and operating systems. That gave rise to this plaque compatible, and that flourished through the 70s and the 80s, and even up to the end of the 90s, because IBM had this very, very small new CMOS processor. And that led me to the next breakthrough, where an IBM patent towards the end of the 90s allowed IBM to build chips based on copper technology instead of aluminum. That reduced enormously the size, and that increased the capacity. So by 1998, 1999, IBM had a processor with a similar or better capacity as the water-cooled machine back in 1992, 1993. Then as we moved up through the 2000s, one of the big things that happened was at the design level, where IBM decided to redesign the processor implementation on the chip and went to a situation where they could actually up the clock rate. We had been running at a clock rate of about 1.6, 1.7, and now with the redesign of the pipe, we could go to beyond 5.0 gigahertz. And this is still the case. This is the fastest chip in the industry. They are running it now at 5.2 or 5.3 gigahertz. Very, very, very significant thing. Going back again to the end of the 90s, Linux was introduced. Linux came around and was brought on to the mainframe. And the investment in VM, as we talked about, the SI instruction in the mid-80s, added to the fact that we could now run hundreds, if not thousands, of Linux virtual machines on a single piece of hardware. Very, very, very significant. And IBM took a bet because, of course, the fear was that the Linux on the mainframe would take away things from the classical side. That didn't happen. The opposite happened. The fact that we brought Linux onto the mainframe increased the need for COS cycles and COS solutions, if you will. Very, very significant. And again, this is my personal view. A large COS shop or large C shop today that does not have Linux, they are losing out on a huge opportunity to bring new workload onto the mainframe. And then of course, at 2011, I left IBM to go into retirement. And my last working day for IBM was actually in Poughkeepsie, New York, in Building 8, where we had just finished the last Red Book that I wrote, right? And then, of course, as we move forward from 2015, I've been then teaching at a couple of universities. I've also been teaching what you would call a commercial class, a 25-day mainframe class, all the way from the hardware into operating systems, subsystems like RACF, like REX, like Unix system services, etc., etc. But right now, at the moment, I'm teaching at these two universities, and I like that a lot. I just got my first class for the next year has been fixed, so I'm very happy with that. Okay, this was a very personal one. There are probably lots of other things I could have been talking about, but those are the things that have marked to me what the mainframe development has become.
Yeah, and throughout your entire career, like you have witnessed various aspects of this IBM technology, the mainframe technology, and you have witnessed like how all these things evolved by the time. So, could you please share some memorable experience from your projects, or I would say, the international assignments that you have worked upon?
Yes, the first one is a very particular one because it was a project that started on a particular day at a particular hour, and it ended 17 days later at a particular date and a particular hour. That was the Lillehammer Winter Olympics 1994, where
Okay.
I was responsible for the capacity and the performance of the mainframe system. At that time, we were still running uh, the old fashioned, so we were running on two 3090s. And what IBM tried to introduce at that time was that we took one of the new smaller 9121 systems that had a lower MIPS rate, but had a much bigger memory. So we basically went through a modification of the, not of the applications themselves, but of the applications environment to take advantage of what at that time data in memory was a big thing. The idea
Yeah.
was, what is the fastest IO you can do? That's the IO you don't do because you have the data in memory already. So that was a very particular project because the games start on a particular day, on a
Mm.
particular hour, and if IT is not ready, the games will go on.
Right.
So that I liked a lot. That was very interesting from a commercial perspective. Probably not a lot, but you know, on TV, IBM technology, etc. The other things are mostly in the area of, say, LPAR. Introducing LPAR to customers was a bliss, because people had been waiting for this. So going to a customer who had a 3090E and telling him, now we have this microcode and other update, and you can now run, at the time you could run two LPARs. So two logical partitions running two different operating systems, if you will.
Mhm.
And then the next one was, of course, the change of technology, as we talked about, because to counter a little bit the loss of capacity, IBM introduced the parallel sysplex. So I joined a team in Montpellier, France, a team that came from the field, that came from the labs, to help customers, number one, understand what was the parallel sysplex, and secondly, help them implement it in such a way that we could a little bit, of course, counter the lack of capacity of the small machine, but also gradually introduce the highly available systems by having, several pieces of hardware joining a parallel sysplex. I think that was a very interesting thing, and we saw big customers, we saw small customers doing that, right?
Yeah.
So, and that we'll probably talk about early support programs. But the other thing that I'd like to talk about was that up through the 2000s, IBM introduced a way of linking the customer directly to the lab. So we had something called the C Atlas team, where we were about 15 to 20 people from around the world that would come to the lab in Poughkeepsie a couple of times, 3 times a year, discussing futures, where IBM would say, we have this system today. Now, the next one will probably have these technologies, and the next one after that will have these technologies, and the next one after that would probably have these technologies. Because you have to remember, at that time, IBM brought out a new mainframe every 2.5 years, but the development cycle was 5 to 6 years. That means that there was always 2 or 3 machines in the coming. And what then this set Atlas team would then do was to go to customers and say, customers that had a certain relationship, if you will, with IBM. So we go to a customer and say, the next machine will have these technologies. And we, IBM, we think we can do these things, right? What is your perception of that? What would be your top 10 of these things that we think we can do? And we did that across the world, and then went back to the lab and says, this customer thinks so, and this customer thinks so. So it kind of helped the customer influence what happened in the mainframe space. And you could then go to that customer, say 3 or 4 years later, and say, remember, Mr. Customer, we talked about this, and you told me you wanted this. Well, here it is.
Yeah.
You see, this is real. Now it's been much more open. Now they have big meetings where they talk to customers about the same thing. At the same time, I also got the opportunity to become what they call a technical advocate for one customer. So you have one customer where you could talk about everything, right? Everything from the lab to the customer. You could talk to that customer. You could say, this is what we think, this is what we are doing. And that was very rewarding also, because you had this opening the discussion with the customer. No salespeople, no marketing people, lab, customer, and me in the middle. Very interesting. I enjoyed that a lot. And then, of course, there's the early support program. Maybe you should talk about that. Is that the good time to talk about that?
Yeah, we can talk about that, like how you executed the early support program for mainframe hardware and the operating system.
Yes, my first experience was my first assignment in London from 90 to 93, and at that time, the big mainframes were big. I mean, they would fill a house, because you had the frames with the technology, you had the cooling, you had the currency converters. So conducting a project at that time was very demanding. The early support program is an idea where you go to a selected set of customers and you tell them, we have this new product coming. It has not been announced. It could be a piece of hardware. It could be an operating system. I was mostly on the hardware side. So you go to the customer and say, please, Mr. Customer, could you help us? Because that's the way it is. Could you help us by having us installing this system at your premises so that we can assure that it can install, that it will perform, that we can maintain it, and you don't pay for that,
Yeah.
right? So we install the machine some months before the announcement, and the customer can then use the machine for whatever he wants to, but mostly to give us feedback, to tell IBM, this piece of work, this TSO workload doesn't perform very well. On the other hand, this DB2 workload performs very well. So, so we could collect information about that. And of course, the maintenance, so that if there was a problem, that our field engineers could actually maintain the system and repair the system. And then at the end of that one, there would be the announcement, and we would bring the machine up to what we call announcement level. And in 99.999 cases, the customer would then buy the machine or rent the machine or lease the machine, whatever. So very rarely would, because the customer could say, I don't want this machine. Please, IBM, take it away. I never saw that happening. So I did that for the big water cooled and the smaller air cooled machines in the early 90s. Then I went back to do the Olympics, and I got another assignment in Montpellier in 95, which was basically parallel sysplex. And then eventually the mission for early support in Europe moved from London to Montpellier, and I said, I think I can do that, because I've done that before. So from that time and until my retirement, I did all the hardware early support programs in Europe and in Asia, in Australia actually, without ever going there. And I also did a couple of Linux VM Redbooks and early support programs and some COS, because the COS early support programs would fall into what I did also. So I basically did COS and hardware from about 2000 up to about 2011. And again, the problems of the big machine would go away, right? Because now the mainframe is like an American fridge. You just stick it on a truck and drive it out to the customer. But the process as such was still the same. Can we install it? Can we maintain it? Can the customer use it? And can the customer feedback to us what he thinks about it, right? So, and that, of course, the ESP could you then combine with, we talked about the C Atlas team, you talked about me being a technical advocate. And then, of course, I wrote the red books. So I had everything on my plate. So all the hardware red books from about 2000 to 2011, I was co-writing those. when I say wrote them, it's not like that. That's a big team, that 8-10 people coming together for 8-10 weeks, where
Okay.
they give you the machine and you can do anything you want. You can stop it and start it, and you have to describe the machine so that the customer can understand what this brings. This is very different from the normal IBM manual. The normal IBM manual is you could almost say a legal document written by IBM, whereas a red book is a book written by individuals. So what
Yeah.
is in the book is coming from the individuals whose name are on the first page. Of course, you had to adhere to all the IBM legal stuff and so on and so forth. So everything you put in there had to be documented, and you had to be argued, right? You had to write in a way that you documented what it was, and also argue why this would be good. So what we did was that we basically took the machine apart virtually and described every single piece that was in there to the customer.
Okay.
My hot point was, of course, the processor itself. So I wrote a lot of the processor stuff, how the processor was defined, how the processor was implemented, and so on and so forth. So when we made this big change, from 1.6 to 5.2 gigahertz, that was a big change. And I enjoyed writing about that. The machine became what we call super scalar, that it could actually finish more than one instruction per cycle, right? The latest, the C16 can do up to 7 instructions per cycle, which is pretty heavy lifting when you look at it, right?
Yeah. Right.
So that was the early support programs. Very, very, very important, and it's still going on. I just a couple of weeks ago I met the colleague who took my job, and he had
Okay.
just retired, and he said, thank you for proposing me to this. This is the most interesting thing I've done in my entire career. He said that.
Okay. Okay. So still it is in process.
Oh yeah, it's still ongoing. Still ongoing. Every time there's a new processor coming out, IBM runs these programs in of course in the US, but also in Europe. And as I said, I actually had a customer out in Australia at the time. So it's an ongoing process that has enormous value to. Don't get me wrong here. It has enormous value to IBM, and it's a customer who helps IBM verify that these systems can install, execute, and be maintained. Right. Of course, there's also an advancement for the customer because he can test new things. Right. You see
Right.
what I mean? Right.
Yeah. Yeah. Right.
The other thing I should say at this time is this is not a hot button of mine, but people talk about COBOL a lot, right? There's a
Right.
lot of talk about how COBOL is running the world. Now, what happens? Now we have a lab. I keep saying I'm no longer the IBM. IBM has a lab in Toronto, Canada, that maintains and develops the COBOL compilers. They have a way of now having the COBOL compiler adapt to the chip technology. So every time there's a new chip coming out for the mainframe, the COBOL compiler team looks at that and say, what can we do from the COBOL compiler point of view to make this thing run faster, right? You see what I mean?
Yeah.
So things like, we have out of order execution. We have these 7 pipes. Imagine now that the COBOL compiler can arrange the code in such a way that these 7 pipes run at the same time. You have a fabulous COBOL implementation there, right?
Right.
We should also talk about Java because there has been a lot of instructions put into the processor to help Java execute. Java on the mainframe is not a dog anymore. It's a very, very well-performing thing because the Java virtual machine is probably the best in the world. It has no stop garbage collection. It has the same thing as we talked about, arranging instructions in a good sequence, right? Of course, it'll not beat a well-written COBOL program, but it's
Yeah.
gone a lot better since we started. Okay.
Yeah. Okay. So yeah, like we have 5 more minutes, so I would like to ask you one more question related to your after retirement lives. So what motivated you to transition your career from like into teaching, and like since your retirement you have been teaching Linux, virtualization, and assembler at a private university in France. So what
Yes.
motivated you to move into this part?
Well, the interesting thing is that I've been teaching all my life. You know, when you are a sysproc, you teach your colleagues,
Yeah.
right? You teach your colleagues. When we modified the operating systems, you had to teach the operators. We have put this thing into place for you guys to use. So I've been parallel sysplay teaching all the time, LPAR teaching all the time. So teaching has been part of my career, but not, if you will, the main. And it has always been clients and colleagues. So this lady that I had known through IBM called me in 2015 and said, "Can't you come and teach?" But this
Mhm.
was a new experience. But this was academic, so you had to note people, right? I don't like that. You know,
Okay.
you have to note them. So and that prompted a thought about the youth. You know,
Mhm.
there's a lot of people saying the youth today is not good and so on and so forth. But I meet these students uh, that are very, very engaged. So I really enjoy that communication with the kids. And now I've been following them now for 9 years. So I've seen them going from their freshman year into their masters. So
Okay.
it's extremely rewarding from a humanity point of view to see these people um, succeed in their careers. The
Right.
problem is that none of my classes are mainframe classes, right? There's not an official mainframe class. So what I do is
Okay.
I say, well, we are teaching Linux. I'm going to install Linux on your PC. And then I'll have you connect, Marist College in Poughkeepsie, New York
Mhm.
offers Linux virtual machines to anyone who wants to do that.
Okay.
So they give you a virtual machine with two processors, 4 gigabytes of memory and 50 gigabytes of disk space.
Okay.
So I have my students connect to that and install Ubuntu, SUSE Linux, Red Hat, and now also Alma onto their virtual machine over there. And when they've
Okay.
done that, I just ask them, now use your imagination, put everything up there, make a web service, make a database, etc., because you have this thing for 120 days and you can renew it if you want to.
Right.
So the message here is Linux is Linux is Linux. Linux on your PC and Linux on this big machine that runs thousands of students. The environment is different, right? It's very different. And I use the same thing for virtualization, of course. I use this is running on VM on the mainframe and Marist, but I also teach some things like VMware, VirtualBox, Proxmox, where they basically virtualize on their PC or on some servers that the university has. So the virtualization again is the concept is similar, but the implementation is very different. Like we talked about, the VM LPAR implementation on the mainframe is absolutely unsurpassed. It's fabulous. Now the assembler is a little bit difficult because uh, to join the Marist College system for the COS side, you have to be a member of the IBM Academic Initiative, which I am now. So I use Marist College COS side, and I show them, ISPF, but I also show them SOE. You heard about SOE, of course,
So
this
yeah.
open source. So
Yes.
so you have the students have ISPF on one screen, SOE on the same element on the other screen, and I think
Okay.
that's fabulous. Now then, lastly, I'll finish with that.
Hmm.
Some of these students don't have a high bandwidth um, internet at home.
Hmm.
So I found many years ago something called Hercules. And now that Hercules has developed into something that's called TK5, turnkey number 5, which is basically an implementation that is packaged with an MVS system 3.8J, uh, early 80s, but the last one that was in the public domain. So the students can install that on their PCs, Linux, Windows, or Mac, and then install an open source TN the X3270 and then run the mainframe on their local systems. It
Okay.
doesn't have all the new things. It doesn't have all the new instructions, but the students can run basic assembler, COBOL, ALGOL, Fortran, whatever, on that particular system. And I use that extensively. So as I said, none of my classes are mainframe classes. All of my classes has heavy mainframe content. Okay.
Okay. Yeah. So thank you so much, Carl, for joining us today and for sharing all these expertise with us. It's like really very pleasure to hear about like how mainframe is evolved, how you are teaching, and you're teaching like I would say that it's a practical approach, like right, because you are allowing student to do the practicals and by the hands-on they are learning the things. So it's
Yes.
quite inspiring for all the teachers also, like who are teaching these technology, so they can also try to use this approach in order to explain the things in a much better way. So thank you once
If
again.
anyone
Yeah.
if anyone in your environment
Hmm.
wants to talk to me about what we talked here, especially the education part, please feel free. I have
Yeah.
a lot of, I'm retired. I don't teach more than 100 to 200 hours a year. So I've got a lot of free time, and I would be very delighted to speak and talk to people from your environment if ever needed. So from me, thank you very much for having me. It was a great honor to meet people like yourself, and I appreciate what the team has put into this. So thank you. Thanks a lot.
Thank you, Carl.